First, I'd like to thank all the symposium organizers, and especially Professor Kanamura, to invite me here and to give me a chance to participate in this symposium. Being here, I felt like I was watching a very high quality TV programs of, say, National Geographic. So I hope that I can contribute something to you. Okay, before starting, I have to tell you that when I practice my presentation, it took 1 hour. So I have to make it short. Okay, my talk is about sharing insurance risk by trading security, specifically CAT index futures. Okay. Now, in this symposium, we are talking about disasters. My talk is not about existential risk, but much smaller risk. But in any case, disasters causes economic losses. And we have been talking about preventions and mitigations of those disasters. But anyway, economic losses are inevitable. And for these economic losses, it is beneficial to share it. Sharing risk of economic losses is beneficial economically to everybody. And traditionally, there is insurance and reinsurance. Those guys worked for that, still working for the risk sharing. But recently, we had a sort of an invention of so-called insurance-linked securities. We call it ILS, for risk sharing, not in insurance or reinsurance market, but in the capital markets other than reinsurance market. Okay? And this is an image of insurance or reinsurance. Now here, the insurance companies sell their insurance to their clients, and the clients is exposed to some, say, risk. And after selling the insurance companies are bearing those risks. And those insurers insure each other and share the risk that they bear from their client. That's the idea of the reinsurance market. All right? And this and the ILS, the insurance-linked securities, is created actually in 1990s, okay, as a sort of one application of derivatives or securitized products. Okay. And ILS, what is ILS? ILS is securities whose payoffs are determined according to amount of insurance losses. One example of ILS is CAT bond, catastrophe bond. That is a bond whose payoff is reduced when CAT event occurs. So the payment is reduced when insurance losses occurs. Okay. And another example is CAT index futures that I'm talking about in this presentation. It's a futures contract whose payoff is reduced according to losses by insurance companies. Okay? So how do insurance companies use ILS? They take a position in ILS so that the gains from ILS offset losses in insurance. In this way, insurance companies can hedge the risk that they bear, and the investors to ILS take the risk of the insurance. Okay? And why were ILS created in 1990s? Indeed, in 1990s, a sequence of natural disasters caused huge losses among reinsurance, so that the reinsurers cannot take risk of insurers. Okay, so those guys in the reinsurance market needed to find new guys who can bear their risk, and they find them outside the reinsurance market, the investors in the capital market, and to let them bear the risk, they invented insurance linked to securities. Okay. Now, this gives you a sort of a feeling about how why they think this way. Okay. Now here you can see. Indeed, you cannot see, but there is its amount of losses in insurance industries in 1990s. Okay, and the blue one, the next to it, that's the market capitalization of New York Stock Exchange in 1999. So, although this is a loss, the left one is loss, and the blue one is market capitalization. Basically, the loss is within the fluctuation of the value of the stocks. And there are many other stock markets in the world, and also huge bond markets. So from this fact, it seems good idea for the insurers or reinsurers to try to let the investors in the capital market to bear the risk that they face. Okay? And this is cat bond. Cat bonds looks doing relatively well. Here, this is 2007. Okay, this bar shows the amount of issuance of each year, issuance of cat bond each year. And this guy, this is issuance amount of 2007. And we got the Lehman shock here. So the issuance went down, but coming back, and this is 2014. It's exceeded this issuance amount. Okay, so it seems that the cat bonds are doing well, but we need a little bit of caution because 2007 could be a sort of a bubble period, and also the recent demand for the cat bond may be driven by the global low interest rate. So there, investors need some. Investors are searching for high yield. But anyway, cat bonds looks okay. But cat index futures have never been successful. Okay. In 1990s, Chicago Board of Trade and Bermuda Commodity Exchange launched cat index futures, but they immediately failed. And in 2000s, Insurance Futures Exchange, New York Mercantile Exchange, or Chicago Mercantile Exchange launched cat futures. Okay, I put question mark. This is because now I cannot confirm that they are traded. Seems to me that they are gone, but I cannot confirm. So in any case, cat index futures are not popular. Okay, the point that I want you to remember is that trading insurance risk, or behind it the disaster risk, seems very difficult. Okay, that's one point that I want you to understand first. Now, I would like to explain why. Thinking about this simple example, it's easy. Now, here, you are here. This is your house. And here is your fire. Your house catch fire, right? Then you want to share the risk of your house catching fire with somebody else. And now you can do it very easily by buying insurance, going to insurance company and buy some insurance for your house. So it's all right. But I believe that it's very difficult for you to do the same thing with somebody, some rich otomodachi, rich friend in Facebook. If you ask that rich friend that to compensate you when your house catch fire, he or she cannot do that. Okay, but why? One, there may be some legal reason or many other reasons, but one important reason is that insurance companies knows the risk that they will take. The insurance companies, knowing your type of your occupation or say age, your type of your house, the location, they know what kind of risk and how much risk they take. Okay, but your friend in Facebook doesn't know you. Maybe they know your face, but they don't know how much risk they take. Okay. That kind of information, I should say, the information asymmetry between you and your friend in Facebook prevents you from trading your risk. Okay? The situation is the same here. Okay, some disaster. And now the insurer bear the risk of disaster by selling their insurance to their clients. And they want to share that risk with somebody else. And they can do it in a reinsurance market with insurance and other insurers. But I put question mark here because I told you that sometimes this market has a very little capacity to bear the risk. Okay. Although they are all professionals, so they may have the same information about the risk. They understand the risk, but still they may be very small. And the right side, the non-insurance investors in the capital market, the insurer wants to trade, transfer their risk by selling or trading ILS with the non-insurance investors. Okay? I put the question mark here again because although the non-insurance investors have a very huge capacity to bear the risk, they have no information about the risks that they trade. That makes it very difficult for them to trade that risk each other. Okay. Now I just tabulated the result, and insurers bear some insurance risk, wants to transfer that risk to somebody. For the reinsurers, pros is they have the same information, they know, they understand the risk, but they are small capacity. Non-insurance investors, they have large capacity, but the problem is asymmetric information. I write adverse selection. That means a type of asymmetric information that one party, the insurers, knows the risks that they want to trade much better than the investors. Okay, there is one party knows too much about it rather than the other party. We call that situation adverse selection. All right. Now, given this situation, still think that insurers want to transfer their insurance risk to non-insurance investors by trading insurance-linked securities. That's the situations that I want to think about now. Okay, one way to reduce the problem of asymmetric information, maybe somebody provide information about the insurance risk to non-insurance investors. The insurance outside investors now learn something about the risk that they trade. And so the difference of the information, the asymmetric information, is reduced. Okay, there are several information providers about the insurance risk, like Gaikan Penta, that may work for this one. Okay, of course, there is cost for the information, and the information cannot be perfect. Another way to reduce the asymmetric information problem is the following. The insurers can design the payoff of ILS so that the insurers have less information. Now, they trade ILS information in insurance-linked securities, but now insurers has less information about that. Then the problem of asymmetric information is reduced. Okay, that's the idea. And this is the type of the remedy that I would like to think about in this presentation. Okay, this is a little messy, but let me get through. What do I mean by design payoff that is less informative, less sensitive to the information? Suppose that Xn shows the risk that insurer N faces, and F the payoff of security. If the payoff of the security is taken to be Xn itself, in that case, the payoff matches insurer's risk perfectly, so the insurer N is happy because he can trade risk just he wants to. But in this case, adverse selection on F is maximal, okay? Because it's Xn that the insurer N has some information about, right? Now, if the payoff of the security, ILS, is different from Xn by epsilon, and if nobody has superior information about epsilon, in that case, adverse selection on F is reduced, right? However, in this case, insurer N cannot trade the risk that just he wants to. So there is a trade-off between the basis risk and the asymmetric information. And the basis risk is, in this context, is basically the risk that insurer, risk epsilon that insurers I has to bear by trading ILS, whose payoff doesn't perfectly match the risk he wants to hedge, right? And asymmetric information. So, in short, if insurers want to reduce adverse selection problem, then they must take more basis risk. The question is that, given this trade-off, what kind of payoff they want to, the insurers want to accept? Okay, and I would like to analyze this question in a specific context of CAT index futures. Now, what do I mean by CAT index futures? Okay, again, let Xn be the risk that insurers N faces. More specifically, it represents the stochastic random variables of loss from insuring damage by CAT event. Okay, then CAT loss index is defined as average, industry average of CAT loss. Okay, average of XNs. Okay, and the CAT index futures is just the futures whose payoff F is equal to this industry average. Okay. Now, this design of CAT index futures have basis risk as you can see, that the industry average F cannot be the same as the individual loss. Okay, so there is a basis risk. However, by taking average, there is less adverse selection or less asymmetric information. So we'd like to know how to balance between the basis risk and the adverse selection or asymmetric information. Right. Now, again, that's the payoff of the CAT index futures. And if we take a look at it, we immediately notice that if we increase the number, capital N, number of insurance companies for which we take average, then basis risk, we have more basis risk for the insurers, but less adverse selection for the non-insurance investors. That's the trade-off that we will see. And given that trade-off, again, under what condition or for how large N the CAT index futures is traded between insurers and non-insurers outside investors, and also what do investors prefer trading the CAT index futures rather than reinsurance for risk sharing. Okay, to analyze this issue, I use the following model. Okay. We have N insurers, each exposed to insurance risks, and they are informed on insurance risks. And they choose which market they use, the insurance market or CAT index futures, to transfer their risk. When they use the insurance market, they trade their risk with the insurers and a representative insurer and among themselves. And all of them are informed. So there is no asymmetric information. If the insurers choose to trade CAT index futures, they trade CAT index futures with representative uninformed non-insurance investors. Okay? And the question is, what's the condition for CAT index futures are traded, and also what's when insurers prefer to trade CAT index futures. Okay, let me skip it to the detail. Okay, skip this and just to tell you this guy. To solve this information stuff, we have to resort to a very stylized model, and so please allow me that. And basically, this is a utility of the investor. And insurer. Insurer is exposed to the risk given in this form. And here, X represents a per unit payoff of the insurer ends in insurance risk, and E ends shows the size. And we assume that Xn is given by the addition of a non-information part common to everybody, and the information, the part that which is subject to information. Okay, and why I show you for the insurance and the non-insurance investors, things are about the same. And first, I want to find the condition under which the individual risk of insurer N cannot be separately traded with non-insurance outside investor. Okay, basically they are maximizing their utility given the budget constraint. But the big difference here is that this is the insurer who has the information S and uses that information. Non-insurance, uninformed outside investors can only use the information that they can observe in the market. Okay, then equilibrium, we can solve the equilibrium, and we can find this condition. If this inequality holds, lambda is positive, then the insurers' individual risk can be traded in the market. Okay, this looks messy and messy, but the interpretation is very intuitive. It says that basically this part shows a trade motivated by hedging, non-information trade. And this part, this is information, a trade motivated by information. So trade motivated by hedging, if the trade motivated by hedging is larger than the trade motivated by information, then the uninformed guy is willing to trade. Okay, that's the idea. Now, I would like to think about the situation where individual risk cannot be traded. So I assume that lambda is non-positive. And the question is that given this, can they trade cat index futures? And do the same thing for the cat index futures. Now, sorry, this should be F. And the payoff is different. And we can find a similar result. And basically, this is a condition for the cat index futures to be traded. And the idea is the same. If the trade motivated by hedging is larger than the trade motivated by information, then the uninformed investor is willing to trade, and trade occurs. And as you can see here, if n is large, then this condition is likely to be met. So, if averaging, we are taking the larger averaging for larger number of insurers, then it has the cat index futures have a higher chance to be traded. Right. Okay, so this is just rephrasing what we observed. Now, let me skip. What I want to say is that in short, a cat index futures with payoff being industry average losses is an effective way to mitigate adverse selection and facilitate trading. Now I would like to compare the utility that insurers can get from trading cat index futures with utility from trading the reinsurance. Okay, we do the similar calculation for reinsurance market. And what is different here is that reinsurers have the same information here. Okay? Okay, let me skip. And if the utility from trading futures, cat index futures, is higher than from trading in reinsurance market, then the insurers prefer using the index futures. And this is a stylized model, so I can just give you some example, but the example shows as follows. Lambda, this shows the lambda F. Lambda F is a condition for the cat index futures to be traded. Now, as you can see that for n to be 1 or 2, this guy is still negative. So as the number n goes up, then the condition for the cat futures being traded can be met. And this shows the minimum number for the averaging that makes index futures tradable. And if the variance of the common part are subject to no information asymmetry, then if it goes, then the power of averaging for mitigating the asymmetric information become larger. So we need less number of the averaging. And this is a utility level of from trading the cat index futures and reinsurance. As you can see that as the number of n goes up, then they are going up. But if there are too many average averaging, then the utility from reinsurance may exceed the utility from trading the CAT index futures. Okay. So if there are too many averaging, maybe that reduce the attractiveness of index futures because of the basis risk. All right. Okay, let me conclude. And we found that index futures is an effective way to mitigate adverse selection and facilitate trading. But using industry average as payoff may reduce attractiveness of the index futures for insurers. And that may be part of the reason why CAT index futures were so unsuccessful. And in this model, indeed, we put an assumption that individual risk of the insurers cannot be traded with non-informed outside investor. But that means, at least in this model, we cannot, the CAT bond cannot be traded. Okay? But the fact is that CAT bond is traded and CAT futures is not traded. So to understand that fact, we may relax the assumptions that we put on our model. And finally, in this model, we assume that the insurers trade reinsurance market or capital market. But fact is that the reinsurers may act as an intermediary, and that bridge between the reinsurance market and the capital market. So we need some development to investigate this role of reinsurers. Okay, thank you very much.